Okay, so if you watched the previous video, we were working with the one-link planar robot example, and we were given some of the parameters, and we worked out the rest such that we were given the amplitude, we were given the phase angle, we were given the period, and we used that to find the frequency, the angular frequency, and the phase shift. And then, of course, from that, we were able to write an equation which gave us the y component of the length at a given time. And it turned out to be the amplitude, which was 40, times 2 pi, which is the angular frequency, times our time, plus the phase angle there. And so those were our things to get that. And then it asked us to do a sketch. And so, again, we've already got that information. We took that information we already have from part A that we solved out. We were given these three, solved these three. And they want us to draw this. And one of the hints I want to give you is don't start out by trying to draw an X and Y axis. Almost always when we make a plot, our first thing is we want to draw an X and Y axis. In this case, we do not. So first thing we want to do, we do want to draw a horizontal axis. So I'll try to do that here. And we could even, well, actually, I would not do that yet. I would not label it yet. And then the next thing I want to do is draw one cycle. So again, you guys saw my previous videos. You know I'm not good at this. But we know in general, it kind of goes up, or it'll start at 0, it'll go back up, it'll come back down to 0. And if I can at least hit kind of the main points, then I know it's going to hit there. Maybe I want to stretch this one out so that, because I'm going to have to label a lot of things on this that you'll be able to see. So let's go ahead and make it go from there. 1, 2, 3, 4 blocks back down. 1, 2, 3, 4, and it goes back down. And 1, 2, 3, 4. Yeah, so let's try to draw a nice smooth sinusoid looking curve. But like I've said many times, hopefully it'll be better than that. And I'm going to give a little bit of tail on there to kind of do that. But yeah, that's what. So I want to draw a horizontal axis and then draw one cycle. Don't draw the vertical axis yet. And then I can label horizontal axis. And in this case, it's going to be t, which is measured in seconds. So that's what I want to get to at that point. And then I can start remembering my other things. So remember that some of my other factors, things to remember. One cycle is t. It's our period, which for our example is 1 second. To the middle is t over 2, which is equal to 1/2 second. And then to a peak is only 1/4 of our turn, so it's t over 4, which for us is 1/4 of a second. So I know this whole distance here is 1 second. But what I have to be aware of is the phase shift. So if our phase shift was 0, then I would start with an x this here. If phase shift equals 0, then y-axis starts at beginning of cycle. So in the original example, that was the case, but in this example, we do have a value for, and then of course the phase shift equals 0, that means our angular equals 0. Our angular shift equals 0. So instead, what we want to do is make sure we actually start at negative the phase shift. Is where we want to actually put our axis. So if this were 0, if it were 0, we would start it here. We want to start at negative our phase shift. So, I may have done this somewhat well. Yeah, so I made it to where 16 blocks, if I did this right, so that was good thinking actually, to rearrange my size. 16 blocks is 1 second. Which is my entire period. So my phase shift, which for our particular example is 1/16, so it's negative 1/16. So I want my phase shift, I'm going to have to actually put my axis here. Or I'm sorry, I said that wrong. Not the axis will start there. Cycle will start there. The cycle will start at negative phase shift. So the cycle will actually start at negative 16. So this point here where I start is actually negative 1/16 seconds. So then if I know that, I know that this must be that the end is t minus my phase shift, or it's 1 minus 1/16. It's 15/16. So this point is 15/16. The halfway is t over 2 minus my phase shift. So it's 1/2 minus 1/16, which you'd have to get a common denominator to really work that out. But essentially you should end up getting 7/16. So that's this point, must be 7/16. And my quarter points would equal t over 4 minus my phase shift, which would be, in this case, it's just 1/4. Again, this is becoming easy just because my period is 1. And that gives me 3/16. And if I had to figure it out, my 3/4 point would be whatever 3/4 of t is minus my phase shift. So it's 3/4 minus 1/16, which is 11/16. So these are my main points that are easy to find. And so, of course, my 0 is going to end up being right here at one little part off. And by knowing, where this should kind of be, remember this is at 0, so it's got to be 1/4 of the way in between there, between that, or it's got to be between, it's got to be part of the way there. And so I can put that vertical axis in there. I know this maximum point, so I can label the amplitude. So this is at 40 centimeters, and the farthest it goes down is at negative 40 centimeters. So I do the positive and negative part there. And that's really got all the sketch there. And now it may be, you know, if you have a big phase shift or something like that, where you're way over here, you might have to draw another cycle for it to make sense. But generally they will set the equation, they will adjust the equation such that they either change another parameter or change that. So your phase shift a lot of times is within that first little loop. And so just knowing where that is, like I said, you can wait and kind of do it there. But that's how you would draw a sketch once you've got the parameters.